Hey everybody, today we're going to talk about radicals and how to do operations like adding, subtracting, multiplying, and dividing. And we have a lot of examples to go through today, so let's get going. So a radical expression, first of all, is just anything that has a radical sign. Could be a cubic or a quartic, but most of the time what we're dealing with is square roots. Don't forget that word radicand. Everything underneath the radical sign is the radicand. Okay, so first we're going to look at adding and subtracting since they seem to go together well, and then we'll move on to multiplying and dividing later on. Okay, sorry about this. I must have been on the wrong page. So I'm going back to our beginning. And there we go. Okay, so first of all, when we add and subtract radical expressions, you need to have like radicals. In other words, the radicands have to be the same. I said like radicands, like radicals, same thing. The radicals have to have the same radicand. So for instance, radical 3 plus radical 5, you just can't go any further. You can't combine those two together. But if I have one radical 3 plus four more radical 3s, I have the same radicand 3. I can combine them up for 5. They have to be the same. This is a lot like when you were doing common denominators and like terms of polynomials. So, for instance, over here, I have radical 5 plus 6 radical 5. I can put those two guys together to make 7 radical 5. But the 4 radical 3 has to stay aside. It can't be combined up. Sometimes, though, if the radicands aren't the same, you can make them the same if the radical isn't fully simplified. Here's an example of this. I have the square root of 72 plus the square root of 8. Well, 72 is 36 times 2, so I can pull out a perfect square factor, which I do right here. Over here, 8 also has a perfect square factor, so 8 simplifies to 2 radical 2. The square root of 72 simplifies to 6 radical 2. And now, all of a sudden, I have the same radicand. My radicals are alike. So 6 of them plus 2 more radical 2s gives me 8 radical 2s. Over here, the same idea. We simplify radical 32 and radical 18. That's done right here. As it turns out, we have 5 times 4 radical 2 minus 4 times 3 radical 2, and we end up with 8 radical 2. All the work on simplifying is done over here on the right. Okay, so adding and subtracting is done. We need those like terms or like radicals. Now let's talk about multiplying. First of all, they're numbers. They're real numbers. So they're going to follow all the same rules as what was set up before. They commute, they associate, there's identities, all that stuff. And the other thing is that we want to recall that if I have a product, I can break it apart or put it back together. This is bidirectional. An equal sign means that radical A times B is radical A times radical B, and vice versa. So first of all, I have radical 2 times radical 8. So I'm going to take the 2 and the 8 and multiply them together. As it turns out, that's 16, and radical 16 is 4. So hey, an irrational number times another irrational number might be rational. Here's another example of multiplication. Since they're all real numbers, they do follow the distributive property. I'm going to take radical 2 and distribute it into the radical 8 plus radical 10. We do that right here. Combine up terms, simplify. Don't forget, 20 is 4 times 5. 4 is a perfect square. We pull out that perfect square factor. So we see also now I have a rational number 4 plus an irrational number, and those are always irrational. So some more stuff about multiplying. We have 7 times radical 28 plus radical 63 right here. We do some simplifying. Combine up our like terms, 2 radical 7 and 3 radical 7 gives us 5 of them. Radical 7 times radical 7 is 7. 7 times 5, and we end up with 35. Over here, the same idea. 5 times 8 is 40. 7 times radical 5 is right here. 40 has a perfect square. 4 times 10, so we pull that perfect squares factor out. Now notice that we're using the distributive property. And before, when we multiply binomials, we use that distributive property twice. Here's an example of it down at the bottom of the screen. But let's move on and try this with radicals. Let's say I have a radical number, 7 radical 8 plus 2 radical 11. times another radical number, 3 radical 8 minus radical 11. Well, we're going to use FOIL just like we did with binomials, or the distributive property twice if you prefer. We're going to take 7 radical 8 and distribute it into the 3 radicals 8 minus radical 11, and then we're going to do the same thing with 2 radical 11 second. We end up with first, outer, inner, last. Notice, for instance, radical 8 times radical 8 is 8. 7 times 3 is 21. So I wrote it down as 21 times 8. Over here, I combined it up. I have 2 times radical 11 times minus radical 11. First of all, the negative sign came out right here, right there. Radical 11 times radical 11 is 11 times 2 is 22. Okay, so we combine up our like terms. 7 radical 88 plus minus 7 plus 6 ends up with -1 radical 88. 88 has a perfect square of 4 in it, perfect square factor, and fully simplified, there's our answer. So onward to division. So the thing to remember is that you can't have radicals in the denominator. And we do have a rule. We can break up our quotient. We can talk about the square root of a quotient is the square root of the numerator divided by the square root of the denominator. If I am dividing by a rational number like radical 3 over 2, that's no problem. It's done. That's fully simplified. If I have radical 8 over 2, I know radical 8 can be simplified into 2 radical 2. And notice that those guys will cancel, and my final answer ends up being radical 2. So simplify. So what happens, though, when this denominator is irrational? We can't have radicals in the denominator. So we're going to have to make it rational. And we've seen this before. I multiply by 1. If I have 2 over radical 3, I take that and multiply it by 1. Radical 3 over radical 3 is equal to 1. So 2 times radical 3 is 2 radical 3. Radical 3 times radical 3 is 3. And there is my simplified version. 2 divided by radical 3 is not simplified. It has an irrational number in the denominator, a radical. Okay, a few more examples just to whiz right through. We're going to divide out, multiply out, I should say, by 1. Those radicals in the denominator will multiply by square root of 7 over 7, or radical 12 over 12. Even variables work down here. Radical x over radical x is still equal to 1. So 5 divided by radical x, fully simplified, is 5 radical x over x. It also pays to simplify your radicands down, pull out those perfect squares. But now what happens, if you notice, all the denominators have one term. What happens when I have 2? Let's see what happens. Well, I'm going to try, I have radical 3 plus radical 5. Let's try multiplying by radical 3 over radical 3. That's 1. That gives me radical 6 upstairs, and then I get radical 3 times radical 3 is 3. Radical 5 times radical 3 is radical 15. I still have a radical in my denominator, so that's not good. Let's try something else. How about if I multiply it by itself? Well, that turns into a big mess that's even worse. This wasn't hard to do, though, because this is a plus b times a plus b, and if you recall that was a squared plus 2ab plus b squared. But the point is, it's not getting any better. But let's go back to when we were factoring polynomials and we talked about the difference of 2 squares, a squared minus b squared, and it was a plus b times a minus b. So if I take a plus b, and then in this case, I'm going to have radical 3 plus radical 5, like this guy up here, and multiply it by radical 3 minus radical 5, it's going to be a squared minus b squared, radical 3 squared minus radical 5 squared. And the squaring is nice because it gets rid of that radical for us, and this becomes 3 minus 5, which is -2. And all of a sudden, I took this sum of 2 irrational numbers, and by multiplying it by radical 3 minus radical 5, we got a rational number, -2. And we got rid of it, of course, because of the squaring. So I'm going to take radical 3 plus radical 5 and multiply it by radical 3 minus radical 5. I know the result will be -2. Of course, I have to multiply by 1. So I'm going to take radical 3 minus 5 and put it over itself. I'm multiplying by 1. Okay, So a squared minus b squared, we already know what that's going to be. Radical 2 times radical 3 right here is radical 6. Radical 2 times minus radical 5 is minus radical 10. A squared minus b squared, if you recall from before, was negative 2. So radical 6 minus radical 10 over minus 2, I just multiplied the top and bottom by negative 1 to get that negative sign out of the denominator. And there's our final answer. This idea of multiplying something plus and something minus, these are called conjugates. That's a good word to know. That's quite common in math. That's a big math word. Now, they're just the sum and difference of the same two terms. And we've seen this before, like a plus b times a minus b. That was our difference of squares, right? A squared minus b squared. But conjugates apply in all kinds of different contexts. Here's a conjugate pair. Here's a conjugate pair. Notice it's the same two things being added and subtracted. All right, so let's use these conjugates to simplify some of these radicals. We have 3 over 4 plus radical 5. We're going to multiply by the conjugate of 4 plus radical 5, which is 4 minus radical 5. And of course, I have to multiply by 1. There's 1 right there, as it turns out. After all my reducing and simplifying, 16 minus 5, 4 squared minus radical 5 squared is 11. 3 times 4 was 12, and then 3 radical 5. And there's our final answer. Over here, I had radical 15 over 2 minus radical 3. We're going to multiply it by 1 using the conjugate. We end up with 4 minus 3 in our denominator, which is 1. Upstairs, I have 2 radical 15 plus radical 45. Well, 45 is 9 times 5, so we're going to pull that perfect square factor out. Square root of 9 is 3. So we end up with 2 radical 15 plus 3 radical 5. Don't forget my denominator was 1. Here's 1, a quick little one. I'm going to multiply. You don't have to multiply by the whole denominator, just the radical part. So I'm going to multiply by square root of a over square root of a. After our simplifications where a gets canceled, radical a times radical a was a, we end up with radical ab over b. Then finally, here's an example out of the book. I picked this one out because it looked like a tough one. We have this expression that we want to simplify. So first thing I do is I look at things like radical 9 and say, wait, that's equal to 3. And we can simplify radical 12 also. So I did all that right between this step and this step. And here's where I multiplied by the conjugate of the denominator. I had 3 minus radical 6, so I multiplied by 3 plus radical 6. And of course, I had to make that all equal to 1, and there's equal to 1. Equal to 1. Okay. Do the multiplying in the numerator. Thank you. There's a little bit of attention to detail there. We have a squared minus b squared. 3 squared minus radical 6 squared is 3. Notice that all these coefficients, 12, 12, 9, and 18, are all divisible by 3. So that's what I did for my last move. I just divided out everything by 3. I know that seems like a lot, but I'll tell you, doing practice problems in your notebook or on Delta Math will really pay off. These aren't too hard, but they are sometimes tedious. So hang in there. You'll get it. If you're not getting it with some practice, you sure will. That's it. Send me an email if you have any questions. Hope everybody's okay.